been thinking quite hard about a maths joke to introduce chapter 11. Turns out it's quite difficult. Suffice to say that chapter 11 is integral to the whole of core 2. Moving on then. Integrating this function here is not too difficult. It's something that you did in core 1. So you should find that this S sign at the top here, if I highlight it in green, is familiar to you and tells you to integrate. The difference this time is simply that you've got some numbers here, so what we call limits. And it's going to allow us to do something called definite integration, which is pretty much just substitution and helps us to find areas under curves. So first of all, we're going to do exactly what we do in core 1. We're going to integrate the thing that's in the brackets there. So I'm sure you'll remember we raise the power by 1 and divide by the new power. Just do that one quickly. Now, when we're doing definite integration, we don't actually need to put the plus c part, and I'll come to that, the reason for that in a minute. So we put it in square brackets, so we've just integrated there, and we've put it in square brackets and we've put an 8 and a 1. So we've done the integration part. What we've now got to do is actually substitute in some values. So first of all, we substitute in the 8, the upper limit, into this expression in the middle, and then we take away the same expression but with 1 substituted in, the other limit. So let's have a go at that. It's easy if we do it. 8 to the power of 2/3 is going to be the cube root of 8 squared, which is 4 over 2/3, plus x squared, well 8 squared, 64, minus x minus 8. So that's the expression when x equals 8. We're then going to subtract, because we always subtract, the value of the expression when x is 1, which is 1 over 2/3 plus 1 minus 1. And all we have to do then is deal with the fractions. Sometimes they're awkward, sometimes they're not. If we just shrink this down a little bit, we should be able to tidy up our answer. The reason that the c is not needed is it would be here in this one, but then we take it away in the next bracket, and therefore it always would cancel off. So therefore we can leave out the c when we're doing definite integration. So just tidying this up, we've got 4 over 2/3 is 4 times 3 over 2, which is 12 over 2, or 6, plus 64 minus 8 is plus 56, minus 1 over 2/3 is 1 times 3 over 2, which is 3 over 2, and the 1's cancel off. So it looks a bit messy, but 6 plus 56 is 62, 62 minus 3 over 2, and they tend to end up like this with awkward fractions, and once again we want to leave it top heavy, so this is 124 minus 3, 121 over 2. That would also, we'll find out later, tell us the area under a curve. So if we could sketch that curve, which is pretty difficult, let's say it looks something like this, then between x equals 1 and x equals 8, then this integral and the actual definite integral, the actual number, would tell us the area under this curve. And you might want to think briefly about how that could be useful in mechanics. What sort of graphs in mechanics would you like to find the area under?